So you have learned that we use classes to bundle data and functionality into one unit. Now, as you work on larger programs, you may come across classes that don't have any behavior. They don't have any methods. They only have data. Here's an example. We have this point class that has two attributes, x and y. It doesn't have any methods. Now with this, we can create 2 point objects. So P1, we set it to point of 1 and 2, and P2, the same. Now, when we compare these two objects and print the result, we get false because these two objects are stored in different locations in memory. So by default, Python compares objects based on where they're stored in memory. If two variables are referencing the same object in memory, they're considered equal. In this example, our point objects are in 2 different locations, even though they have the same attributes. So to prove this to you, I'm going to call this built-in ID function. This returns the address of the memory location where an object is stored. So let's look at the address of P1 and also P2. As you can see, these objects are in 2 different locations in memory. So to solve the issue with comparing point objects, we need to come back here and implement a magic method, EQ. This method takes self and other, and here we should compare self.x with other.x and self.y with other.y. Now, when we compare these two objects, P1 and P2, we get true. So the problem is solved. However, writing all this code for data classes is a little bit tedious. If you're dealing with classes that have no behavior, no methods, they only have data, you can use a named tuple instead. Let me show you how that works. So let's delete this. On the top, from the collections module, we should import the named tuple function. We call this function. As a first argument, we specify the name for this new type we want to create. So we're going to call that point. So note that I'm passing a string here. Now, as a second argument, we pass an array of field names or attribute names. We want our point objects to have 2 attributes, x and y. So this returns a name tuple that we can store here. Note that I'm using Pascal naming convention because point here represents a type, like a class. So we can call it to create a new point object. However, instead of passing these arbitrary values here, we should pass keyword arguments. So we set x to 1 and y to 2. The first improvement here is that our code is more clear and less ambiguous. We don't have to wonder, what are these values? Now, point is a simple concept. It's easy to guess that 1 and 2 represent x and y here. But sometimes when creating objects, you might have to pass some magical values, and someone else reading that code, they don't know what these values represent. So these keyword arguments make our code more clear. The second benefit is that we don't have to explicitly implement a magic method to compare 2 objects. So if we have 2 point objects with the exact same attributes, we can easily compare them and we get the result that we expect. So if you're working with classes that have only data and no methods, you might want to use a named tuple instead. You will write less code. And these named tuples are better than regular tuples because here we'll have attributes in this point object just like the attributes we have in our classes. So if we print p1.x, we see 1. Just be aware that these named tuples are immutable, which means once we create them, we cannot modify them. We cannot mutate them. So if I set p1.x to a new value and run the program, we get an attribute error because we can't set an attribute of a named tuple after we initialize it. So if you really need to modify one of these values, you need to create a new point object. So we set p1 to a new point with x set to 10 and y set to 2. So this is all about named tuples.